Picture a silent traveler hurtling through the void of space for eons, its icy heart.
In the summer of 2025, astronomers around the globe turned their telescopes skyward, captivated by a cosmic intruder unlike anything they'd ever seen. This was no ordinary comet named 3IATLAS. It was only the third interstellar object ever detected in our solar system, and it was rewriting the rules of cosmic chemistry with every passing moment. As Professor Brian Cox, the renowned physicist, put it in a statement that sent shock waves through the scientific community. The gas coming from 3IATLAS doesn't match any known comet. This wasn't just a scientific curiosity. It was a challenge to everything we thought we knew about the universe. Buckle up, because this story will take you to the edge of human understanding and leave you wondering, what is 3IATLAS and what does it mean for our place in the cosmos? Comets have long been the poets of the night sky. Their glowing tails painting stories of the universe's ancient past. Often called dirty snowballs, they're icy relics from the dawn of solar systems, carrying secrets of creation in their frozen cores. As they swing close to the sun, their ices vaporize, releasing spectacular clouds of gas and dust that form the iconic coma and tail. For decades, NASA and the European Space Agency, ESA, have studied these cosmic wanderers using spectroscopy to decode their chemical fingerprints. It's like shining a flashlight through fog. Each molecule scatters light in a unique way, leaving telltale lines that reveal what the comet is made of. Water vapor has always been the star of the show, dominating the coma of nearly every comet we've studied. Carbon dioxide and carbon monoxide play supporting roles, but they are usually far less abundant, with water outshining them by at least 3:1. This predictable recipe has held true for comets from our solar system's Oort cloud, the Kuiper belt, and even the second interstellar visitor, 2I, spotted in 2019. But 3IATLAS, it's tearing that recipe apart. Imagine the moment astronomers first pointed the James Webb Space Telescope JWST at 3IATLAS in early 2025. The data streamed in and jaws dropped. Instead of the familiar glow of water vapor, the spectra blazed with carbon dioxide. 8 times more abundant than water. 8 times. No comet in our solar system, not even the oddballs, comes close to this ratio. Carbon monoxide, usually a reliable sidekick, was barely a whisper with a ratio to carbon dioxide of just 0.2. And then came the real kicker, a flash of pure nickel vapor glowing brightly in the coma with no trace of iron to accompany it. In every comet we've studied, nickel and iron vaporized together, their ratios mirroring those found in meteorites and the sun itself. Here, the nickel to iron ratio soared 10 times higher than anything ever recorded. This wasn't just a chemical quirk. It was a cosmic rebellion. Observatories worldwide, from PH to the Very Large Telescope VLT in Chile, confirmed the findings. The data was real, undeniable, and utterly baffling. What kind of object could produce such a signature? And what did it mean for our understanding of the universe? To grasp the magnitude of 3IATLAS's anomaly, let's step back and explore the chemistry of comets. Most comets are born in the frigid outskirts of a star system, where ice is like water, carbon dioxide, and carbon monoxide freeze solid, trapping dust and gas from the primordial nebula that bear their parent star. As these comets approach a star like our Sun, its heat triggers sublimation, the process where solid ice turns directly into gas. This outgassing creates the glowing coma and tail that make comets so mesmerizing. Spectroscopy, the science of decoding light, reveals the ingredients of this glowing cloud. Water vapor typically dominates, making up 70 to 90 of the gas in a comet's coma. Carbon dioxide follows, usually at 5 to 30 of water's abundance, while carbon monoxide is even rarer, sometimes barely detectable. The Rosetta mission to Comet 67P Churyumov-Gerasimenko in 2014 to 2016 cemented this pattern, showing water vapor pouring off the nucleus with carbon dioxide and carbon monoxide trailing behind. Comets like Hale-Bopp and Hyakutake followed suit, as did 2I, Borisov, the interstellar comet that played by our solar system's rules. But 3IATLAS laughs in the face of these conventions. Its carbon dioxide emission band at 4.3 microns overwhelmed the faint water signal with a ratio of 30 molecules of CO2 for every molecule of H2O. This is unheard of. Most comets max out at a third as much CO2 as water. Carbon monoxide, which should be a close companion, barely registers. And the nickel, it's like finding a single ingredient in a recipe that doesn't belong, like chocolate syrup in a salad. In our solar system, nickel and iron are cosmic twins, always appearing together in predictable proportions. Yet, 3IATLAS emits nickel vapor in abundance, while iron is conspicuously absent. Teams at observatories like ALMA and KEK scramble to double-check their instruments, fearing a glitch. But the data held firm. This wasn't an error. It was a new kind of cosmic chemistry. One that no lab on Earth could replicate. The implications are staggering. If 3IATLAS is a comet, it's unlike any we've ever seen. Its chemical makeup suggests it formed in a star system where water was scarce and carbon dioxide reigned supreme. Could it be a relic from a planet-forming disk so alien that our models can't even imagine it? Or is it something else entirely? A fragment of a cosmic catastrophe? A shard of technology or a messenger from a process we've yet to discover? The astronomy world is buzzing with questions, and the answers could redefine how we view the building blocks of planets, stars, and maybe even life itself. If you're as intrigued as I am, stick around. This mystery is just getting started. If 3IATLAS's chemistry is a puzzle, its path through our solar system is a full-blown enigma. Orbital mechanics is supposed to be a solved science. Plug in an object's mass, velocity, and the sun's gravity, and you can predict its trajectory with pinpoint accuracy. For decades, this has worked for comets from our Oort cloud and beyond, including 2I Borisov, which followed its predicted path like a well-behaved guest. But 3IATLAS is a rebel. When astronomers first tracked it in early 2025, its hyperbolic orbit marked it as an interstellar interloper, speeding through our solar system at over 50 kilometers per second. Its eccentricity, a measure of how stretched its orbit is, clocked in above 6, clearly not bound to our Sun. Hundreds of observations poured into the minor planet center, each with precise timestamps and error bars. In theory, these should have aligned perfectly with the predicted path. But they didn't. The residuals, the tiny differences between where 3IATLAS was supposed to be and where it actually appeared, kept drifting. At first, the deviation was subtle, about half an arcsec, translating to hundreds of kilometers at the comet's distance. For a nucleus estimated to be 3 to 5 kilometers wide, that's significant. Astronomers initially suspected outgassing jets, the same mini-thrusters that nudge comets like 67P off course. Rosetta's mission showed that just 10 of a comet's surface could generate enough thrust to shift its path measurably. But 3IATLAS's CO2-heavy jets, while powerful, didn't add up. Even with their unprecedented abundance, they lacked the momentum to explain the observed drift. Analysts ran simulation after simulation, tweaking every variable. Jet strength, nucleus size, rotation rate. Nothing worked. The drift persisted, sometimes growing, sometimes shrinking, but never vanishing. For the first time, the standard model of gravity plus outgassing failed to explain an interstellar visitor's behavior. This isn't the first time an interstellar object has challenged our understanding of physics. In 2017, 1I MUA, the first confirmed interstellar visitor, veered slightly from its predicted path with no visible coma or tail to explain the shift. No gas, no dust, just a tumbling shard of rock or ice that refused to obey gravity alone. Theories ranged from invisible hydrogen ices to exotic physics. With Harvard's AVI Loeb famously suggesting the possibility of a solar sail or alien technology, the scientific community leaned toward natural explanations, but the debate never fully closed. Then came 2I's Borisov, which restored faith in the rulebook with its familiar comet-like behavior. Now, 3IATLAS combines the chemical strengths of an unknown world with the orbital defiance of Oumuamua. 3 visitors, 3 wildly different stories. If there's a pattern, it's that the universe loves to keep us guessing. So, what is 3IATLAS? Scientists are racing to answer that question, and the theories are as diverse as they are mind-bending. The most conservative hypothesis suggests that 3IATLAS hails from a star system with radically different chemistry. Imagine a protostellar disk where carbon dioxide ices dominated and water was a minor player. Such a system could produce comets with the CO2-rich signature we see in Atlas. Preserved through millions of years of interstellar travel. The nickel anomaly might point to unique mineral deposits. Perhaps from a world where heavy metals were concentrated in ways our solar system never experienced. Lab teams at MIT and Caltech are chilling vacuum chambers to interstellar temperatures trying to recreate these exotic ices. But so far, no combination matches Atlas's full spectral fingerprint. Another theory dives into the violence of cosmic collisions. What if 3IATLAS is the shattered remnant of two icy bodies smashing together in their home system? Such a cataclysm could expose deep layers rich in carbon compounds or organometallics, creating a fragment with a chemistry unlike anything we've seen. The absence of iron alongside nickel might hint at nanoscale metal phases preserved in the cold of space. Researchers have mixed silicates and carbon compounds in labs, hoping to replicate the signature, but the results are only partial echoes of Atlas's glow. Still, the idea of a cosmic wreck carrying the scars of its past is tantalizing. It's like finding a piece of a puzzle from a game we didn't know was being played. Then there's the radiation hypothesis. Over millions of years in the interstellar void, high-energy cosmic rays and ultraviolet light could bombard a comet's surface, breaking molecular bonds and reshaping its chemistry. This space weathering might explain the CO2 dominance and nickel vapor, transforming Atlas into a chemical oddity. Simulations of this process are underway, but they struggle to reproduce the extreme ratios observed. Each failed experiment adds weight to the idea that Atlas isn't just a weathered comet. It's something fundamentally new. And then there's the idea that makes everyone pause. What if 3IATLAS isn't entirely natural? Avi Loeb, never one to shy away from bold ideas, has suggested that the comet's outgassing could be controlled. Perhaps the exhaust of an engineered device. The president is Oumuamua, whose unexplained acceleration sparked similar speculation. NASA's response is measured, but firm. Extraordinary claims require extraordinary evidence. The data shows an anomaly, not a blueprint, but the possibility, however remote, fuels heated debates in journals and online forums. Is Atlas a natural wonder, or could it be a relic of a civilization long gone? The question is as thrilling as it is unsettling. When Professor Cox's warning hit the airwaves in August 2025, the world took notice. Google searches for 3IATLAS surged over 1,000 in a single month, outstripping even the frenzy around Oumuamua in 2017. News outlets clamored for interviews with astronomers, while science podcasts and YouTube channels raced to dissect the anomaly. Online petitions calling for increased funding to study interstellar objects gathered tens of thousands of signatures, and congressional staffers fielded questions about planetary defense and the faint chance of alien technology. The ESA's press office reported more inquiries about Atlas than any mission since Rosetta's comet landing in 2014. Even late-night talk shows got in on the action, joking about cosmic visitors while marveling at the mystery. For scientists, 3IATLAS is more than a headline. It's a chance to push the boundaries of knowledge. Astrobiologists see it as a messenger from another star system, carrying clues about the chemistry that shapes planets and perhaps life itself. If Atlas's gases are truly unique, it suggests our solar system is just one chapter in a much larger cosmic story. The JWST is scheduled for another round of observations at Atlas's perihelion on October 30, 2025, with ground-based telescopes like ALMA and KEK standing by. Lab teams from Max Planck to Caltech are working overtime trying to replicate the comet's gas signatures in controlled environments. Every failed experiment fuels the urgency, and every new data point sharpens the mystery. For the public, the story is deeply personal. The idea that a piece of another star system is passing through our cosmic backyard, leaving behind a chemical signature no one can explain, sparks a mix of wonder, fear, and hope. It's a reminder that the universe is vast, unpredictable, and full of surprises. Social media is abuzz with discussions. Some speculate about alien artifacts. Others marvel at the science. But all are united by a sense of awe. If you're feeling that same pull, drop a comment below and share your thoughts. What do you think 3IATLAS could be? Your ideas might just spark the next big breakthrough. The arrival of 3IATLAS isn't just a scientific puzzle. It's a mirror held up to our own existence. Comets like Atlas are time capsules carrying the raw materials of their home systems across unimaginable distances. Every gas molecule, every speck of dust tells a story of a star system's birth, its planets, and perhaps the seeds of life itself. The fact that Atlas's chemistry defies our expectations forces us to confront a profound truth. Our solar system is not the template for the universe. Somewhere out there, stars formed with different recipes, forging worlds where carbon dioxide ices dominated over water, where metals like nickel played a starring role in ways we can't yet fathom. This realization is both humbling and exhilarating. It's as if the universe is whispering, "You've only seen one corner of my vast canvas. Keep looking." For astrobiologists, this is a call to action. If Atlas's chemistry hints at a star system so unlike our own, what does that mean for the possibility of life elsewhere? Water has long been the holy grail of astrobiology. But what if life can thrive in environments rich in CO2 or laced with metallic vapors? The implications ripple outward, challenging our assumptions about habitability and pushing us to rethink the conditions under which life might arise. As we study Atlas, we're not just decoding a comet. We're glimpsing the diversity of cosmic evolution, a tapestry woven with threads we're only beginning to understand. So, let's keep asking questions, keep sharing ideas, and keep marveling at the universe's ability to surprise us. What's your take on how Atlas might change our search for life? Drop it in the comments and let's explore this together. There's something deeply human about the way 3IATLAS has captured our collective imagination. It's not just the science, it's the story. This is a tale of a lone wanderer, a fragment of another star system, crossing the galactic void to brush past our sun before vanishing forever. It's a fleeting visitor here for a cosmic moment. Yet, it carries secrets that could reshape our understanding of the universe. That sense of transiency of a once-in-a-lifetime encounter resonates with us on a primal level. We're drawn to mysteries that remind us of our own fleeting place in the cosmos. Our own search for meaning in a universe that's vast and unknowable. The online buzz around Atlas reflects this. From Reddit threads debating alien origins to ex-posts sharing stunning telescope images, people are connecting over this enigma. It sparked late-night conversations, classroom debates, and even family discussions around dinner tables. Why? Because Atlas isn't just a comet. It's a symbol of the unknown. A reminder that there's still so much left to discover. It taps into our curiosity, our fear of the unknown, and our hope that we're not alone. Whether you're a scientist crunching data or a dreamer gazing at the stars, Atlas invites you to wonder what else is out there. Share your thoughts below. Have you felt that spark of wonder? Let's keep this conversation alive and see where it takes us. The mystery of 3IATLAS is more than a single chapter. It's a catalyst for the future of space exploration. Every anomaly like this pushes humanity to aim higher, to build better tools, and to ask bolder questions. As of September 16, 2025, observatories are gearing up for Atlas's perihelion on October 30 when it will make its closest approach to the Sun. The James Webb Space Telescope with its unparalleled infrared capabilities will lead the charge, joined by ground-based giants like the Very Large Telescope ALMA and KEK. These observations could be pivotal, offering a clearer view of Atlas's coma, its nucleus, and perhaps even faint clues about its internal structure. Beyond telescopes, the scientific community is rallying for more ambitious missions. Proposals for interstellar object interceptors, spacecraft designed to chase down visitors like Atlas, are gaining traction. Imagine a probe catching up to an interstellar comet, sampling its gases, and analyzing its composition in real time. Such a mission could unlock the secrets of Atlas's chemistry and trajectory, providing answers where telescopes alone fall short. For now, the data remains incomplete, but the excitement is palpable. Atlas has ignited a global conversation, uniting scientists, students, and stargazers in a shared quest for knowledge. So, what's your hope for the next discovery? Drop a comment with your vision for the future of space exploration, and let's dream big together. The universe is waiting. The story of 3IATLAS is not just a snapshot of a fleeting visitor. It's a chapter in the grand saga of the cosmos. A tale that stretches back billions of years to the birth of stars and planets. Each interstellar object that passes through our solar system is a relic, a fragment of a distant past when gas and dust coalesced into worlds around a far-off star. The peculiar chemistry of Atlas with its overwhelming carbon dioxide and solitary nickel emissions suggests a history wildly different from our own solar systems. Perhaps it was born in a turbulent nebula where volatile gases like CO2 dominated the icy nurseries of planet formation. Or maybe it emerged from a system where heavy metals were forged in unusual abundance due to a supernova's lingering influence. The absence of iron alongside nickel hints at processes we've yet to fully understand. Perhaps a selective vaporization mechanism or a unique mineral composition that survived the harsh journey through interstellar space. This comet is a cosmic historian carrying a narrative written in its molecular structure. And decoding it could unlock secrets about the diversity of star systems across the galaxy. For astronomers, this is a chance to peer into the past, to reconstruct the conditions of a distant world that may no longer exist. For the rest of us, it's a reminder that the universe is a vast archive of stories, each waiting to be read. What chapter of cosmic history do you think Atlas is revealing? Share your ideas in the comments and let's piece together this interstellar puzzle. The enigma of 3IATLAS has done more than spark curiosity. It's forged a rare moment of unity in the scientific community. Across the globe, researchers from diverse fields, astrochemistry, orbital dynamics, planetary science are pooling their expertise to tackle this mystery. At conferences, virtual and in person, the buzz is palpable. Slack channels hum with late-night debates, and collaborative papers are being drafted at a frenetic pace. Institutions like MIT, Caltech, and the Max Planck Institute are running parallel experiments, chilling materials to near absolute zero to mimic interstellar conditions, while others simulate cosmic ray bombardment to test the space weathering hypothesis. Even theoretical physicists are joining the fray, exploring whether subtle gravitational effects or unknown physical processes could explain Atlas's orbital drift. This cross-disciplinary effort is a testament to the power of a single anomaly to galvanize science. It's not just about solving the puzzle of Atlas. It's about building a framework to understand all interstellar visitors, present and future. The public, too, is part of this unity. With amateur astronomers contributing observations and citizen scientists analyzing open-source data, this collective endeavor reminds us that science thrives on shared wonder and relentless curiosity. Have you been inspired by this global effort? Drop a comment with your thoughts on how Atlas is bringing us together. And let's celebrate the power of discovery. Beyond the data and the telescopes, 3IATLAS carries a profound philosophical weight. It challenges us to confront the limits of our knowledge and the vastness of what remains unknown. For centuries, humanity has looked to the stars for answers about our origins, our purpose, our place in the cosmos. Each interstellar visitor from Oumuamua to Borisov to Atlas nudges us closer to a humbling truth. The universe is far stranger and more complex than our models can capture.